Hello everyone, today we will talk about the simultaneous of equations. What is the simultaneous of equations? It is two equations with the same unknowns and they are simultaneous because they are solved at the same time. Now let's have a look on these simultaneous of equations such as a1x plus b1y equals c1 and a2x plus b2y equals c2. We have such simultaneous of equations where x and y are unknowns and a1, b1, and c1 are coefficients of the first equation, a2, b2, and c2 are coefficients of the second equation. Now, they can ask us how many solutions do our simultaneous of equations have. We have three cases for such questions. For example, first case. In the first case, we can say that our simultaneous of equations have infinitely many solutions if the ratio of the coefficients of the first equation to the second one equals to each other. It means that a1 divided by a2 equals b1 divided by b2 equals c1 divided by c2. In such case, we can say that our simultaneous of equations have infinitely many solutions. Now we have the second case. Here we can say that if a1 divided by a2 equals b1 divided by b2, but does not equal to c1 divided by c2, then our simultaneous of equations have no real solutions. And also we have this third case. Here we even don't need this part because we can say that if a1 divided by a2 does not equal to b1 divided by b2, then our simultaneous of equations have one solution. So now, as we know the cases and the rules, we can solve the examples related to these cases. Let's start with the first example. We have such simultaneous of equation like x plus 3y equals 7 and 2x 6y equals 14. Now we can see that we have two equations, and if next to x we have no number, it means that our coefficient is 1. 1 divided by 2, here's 3, this is 1, this is a1, b1, and c1. And this is c2, b2, and a2 respectively. Equals 3 over 6 and equals 7 over 14. Yes, they are equal because if we will simplify the second and third one, we will get 1 over 2. So 1 over 2 equals 1 over 2 equals 1 over 2. It means that a1 divided by a2 equals b1 divided by b2 and c1 divided by c2. In such case, we know that we have infinitely many solutions for these simultaneous equations. Now let's discuss the second example. For example, we have x plus 3y equals 7 and 2x plus 6y equals 21. So here, if we will take the coefficients, we will get 1 over 2, 3 over 6, and 7 over 21. We can see that 1 over 2 equals to 3 over 6 because if we will simplify it, we will get 1 over 2. Yes, they are equal. But 1 over 2 does not equal to 7 over 21 because if we will simplify this, we will get 1 over 3. So now we get a1 divided by a2 equals to b1 divided by b2, but does not equal to c1 divided by c2. In such case, we know that our simultaneous of equations have no solutions. We have no solutions for this simultaneous of equations. And now let's discuss the last example related to these cases. Here we have x plus 3y equals 7, and 2x plus 9y equals 21. So now let's take these coefficients 1 over 2, 3 over 9, and 7 over 21. We can see that 1 over 2 is not equal to 3 over 9 because it's 1 over 3. So we even don't need this part because a1 divided by a2 does not equal to b1 divided by b2. In such case, we don't need even c1 divided by c2 part because we already know that the simultaneous of equations have one solution. So that was it for the examples related to how many solutions do our simultaneous of equations have. We know when we have one, when we have no, and when our simultaneous of equations have infinitely many solutions. Now let's discuss how we can find the unknowns in our simultaneous of equations. We have different methods, and for example, let's consider such simultaneous of equations equals 20 and 6x minus 5y equals 12. First of all, let's write y under the y and x under the x so we can clearly see what do we have. 20 minus 5y plus 6x equals 12. So now we have different methods. For example, the first one is substitution method. Here we can take first equation and take from it y. Make y subject of the formula, and we have 12 minus 2x. Now we know y is equal to 12 minus 2x. We can take this equation and put it instead of this y, so we can have only one unknown. Minus 5, 12, 20 minus 2x plus 6x equals 12. Now in this equation we have only one unknown, which is x, so we can easily find it. Minus 100 plus 10x plus 6x equals 12. 16x equals 112. So from here x equals 7. Now as we found that x equals 7, you can just put it in this equation and find the y. Y plus 2 multiplied, instead of x we write 7. 12. Y equals 20 minus 14. So 6. So we found the unknowns of our equation, simultaneous of equation, x and y equals to 7 and 6. That was the first method. Now let's discuss the second one. So y, again the same one. Here we can multiply one of our equation by number, such that if we will add them or subtract them, we will get rid of one unknown. For example, let's take x. First of all, let's write x under the x and y under the y. So we multiply the first equation by 3, because we can see that if we will multiply this equation by 3, we will get 6x, and if we will subtract them, we will get 0 instead of x. So we will come up to the equation with one unknown, such as y, and we can easily find y from this equation. What do we have here? 3y plus 6x equals 60 minus 5y plus 6x equals 12. So now let's subtract them. Let's subtract from first equation, second one. So now what we get here, 3y minus 5y plus 6x minus 6x and 60 minus 12. 3y minus 5y give us 8y because 2 minus give us plus, and 6x minus 6x give us 0. 8y equals to 48. From here we get y equals to 6. Y equals 6. Now we can find x. We can just write this y instead of this, for example. Instead of this y, we write 6 plus 2x equals 20. So 2x equals 14 and x equals 7. So we get the same result as in the first equation, as in the first simultaneous of equations, which we solved by substitution method. X and y equals 7 and 6. So we solve the same simultaneous of equations by the different method, but we get the same result. It means that these methods are true, and we can use them to solve our simultaneous of equation. So we have the last one. It's quadratic equations. For example, x let's consider such example. X squared plus 3x minus 1 equals y, and x equals y minus 2. Now we see that this is not the linear simultaneous of equations. The first one is quadratic. And for example, they ask how many solutions do our simultaneous of equations have. Here we should look at the discriminant. But first, let's take this x and put this value instead of this unknown. So what we get here? Y minus 2 squared plus 3y minus 2 minus 1 equals y. Y squared minus 4y plus 4 plus 3y minus 6 minus 1 equals y. From here, we can just simplify this equation. We get y squared minus 4y plus 3y give us minus y, and also this minus y. Now minus 2y, and these three coefficients, 4 minus 6 minus 1 minus 3 equals 0. Now we should look at the discriminant, because we know the rule: if discriminant is more than 0, then we have two real solutions. If discriminant is equals to 0, we have one solution. And if discriminant is less than 0, then we have no solutions. So what is the discriminant? We know that it equals to b squared minus 4ac. I want to remind you that our quadratic equation looks like ax squared plus bx plus c equals 0. So from here, these coefficients b, a, and c, discriminant equals to b squared minus 4ac. And here it is 2 squared 4 minus but here minus 3 plus 4 multiplied by 3, so we get 16. Our discriminant is more than 0. Discriminant is more than 0, it means that our simultaneous of equations have two real solutions. But what are they? Let's find these values. Yes, what they equal to. So let's solve this simultaneous of equation. I will rewrite it. So we take this one and put instead of this x. And we remember that we get y squared minus 2y minus 3 equals 0. So now we can find that the root of this quadratic equation are y equals 3 and y2 equals 1, but minus 1 and 3. The rule, the Viet's rule we use here. So as we know the y1 and y2, we can easily find x1 and x2. x1 equals to y1 minus 2, y minus 2. Instead of y, we put 3. 3 minus 2, it means 1. And x2 equals to, we take y2 minus 1 minus 2 minus 3. So we get x1 and x equal y1 equals to 1 and 3, and x2 and y2 equals to minus 3 and minus 1. So we get such solutions to this simultaneous of equations, two of them, because our discriminant was more than 0. So this was the solution to this quadratic equation, and that was all related to this topic. Thank you for your attention. Wish you good luck.